Hello, everybody. Welcome to the presentation of the course Water Supply and Treatment Engineering, initiated by Department of Collegiate and Technical Education. Now, I'm going to discuss about session three. In the session three, the contents are design criteria of sedimentation tank, and after understanding the design criteria of sedimentation tank, uh, we'll design the sedimentation tank. What are the design criteria of sedimentation tanks? See, the main things what you have to keep it in mind while designing the sedimentation tanks are the design criterias. One is the overflow rate, which is 12 to 18 meter cube per day per meter square for type 1 settling. And usually the depth of the tanks are maintained as 3 to 4.5 meter with 1.8 meter as minimum and 6 meter as maximum. And detention times for type 1 settling is 4 to 8 hours. Rectangular tank formula is BLH by Q, and circular tank may be calculate in circular tank you can calculate the detention time by the formula d square is equal to 0.011 d plus 0.785 h. Horizontal flow velocity is generally assumed to be 0.15 to zero point 0.9 meter per minute, normally kept as zero point 0.3 meter per minute, and length is equal to 1 to 4 times the width. So whatever the width you take, 4 times of that is generally taken as length. And see here, most of the suspended particles which are present in the water settles as discrete particles. So it is for type 1 settling, it is 12 to 18 meter cube per day per square. Now with this, the details, let us go to a design. Okay, here a design is there. Design a rectangular sedimentation tank to treat 2.4 million liters of raw water per day. Detention period may be assumed to be 3 hours. So, what is the design of a tank? It is nothing but finding out the dimensions of the tank to treat the water. So, raw water flow is 2.4 into 10 to the power 6 liter, which is given. I have converted it into meter cubes, 2400 meter cube, and detention period is has already been given in the question. It is 3 hours. So, raw water to be treated is 2400 liters per day, 2400 meter cube per day. So, what is the volume of the tank required? So, what the volume of the tank required is equal to mm, flow into detention period. Flow that is 2.4 into 10 to the power 3 divided by 3 hours. 3 hours is converted into 24. So, it is 300 cube. 2400 divided by 3 mm, divided by 24 because we have to convert this into meter cubes. So it is 300 meter cube. Let us assume water depth as 3 meters h. So when the water depth is assumed 3 meter, what is the surface area required? AS is equal to volume divided by depth. 300 by 3 is 100 meters square. That is the surface area of the required. So we know that length of the tank is generally not more than 4 times the breadth. Let us assume L is equal to 3B. So L is equal to 3B means 3B square is equal to 100 meters square. So for that is B is equal to, you get 5.8 meter. And as L is equal to 3B, if you multiply 3 into whatever the value you get, 5.8 meter, you get 17.4 meter. So hence a rectangular sedimentation tank with overall size 17.4 into 5.83 can be used. Let us check for surface loading rate. So overflow rating is 2.4 into 10 to the power 6 divided by surface area 100. You get 24,000 liter per day per meter square, which is less than 40 lakh liter per day per meter square. So the design is okay. So I'll explain first. Water to be treated, how much? 2,400 meter cube for a day for 24 hours. So you cannot see simply design 2,400 size. It is a very big size. What it is to be treated in a day, 24 hours. So how much for 3 hours? Quite naturally, for 3 hours period, you get 300 meter cube. So 2,400 flow 2.4 into it is 10 to the power of 6 into 3 by 24. What you get is 300 meter cube. For every 3 hours, 300 meter cube of water to be treated. 300 into 8 times. How much you get? 2,400. So it's fine. So water depth I have assumed H is 3 meters. When you assume water depth, you can find out the surface area. So how do you calculate surface area? Surface area is equal to volume by depth. Volume of the tank, we know for 3 hours it is 300 meter cube. So 300 by 3 is 100 meter square. So once you know the surface area, you can design the size. We can assume L is equal to 3B. Through 3B square is equal to 100 meter square, because L is taken as 3B. So B is worked out to be 5.8 meter. So when it is 5.8 meter, quite naturally length is 17 meter. What you get is a size of 17.4 length into 5 meter width into depth is 3.5. Why this zero point 0.5? Because height of the water is 3 meter and we have a free board, so that water should not come. So zero point 0.5 meter of the free board. So that is why it is 3.5 meter. And we have checked for surface loading rate. Surface loading rate should be less than 40,000 liter per day per meter square. It has come down as 24,000. It's okay. We have another uh, design. Design a rectangular settling basin using these values. Flow rate ಎಷ್ಟಿದೆ 3 lakh liters per day with a detention time of 4, and they have given the velocity of the flow also. Let us start with the rectangular tank. What is the quantity of water to be treated? 3 lakh liters for every day. So ಡಿಟೆನ್ಷನ್ ಪೀರಿಯಡ್ ಎಷ್ಟಿದೆ 4 hours ಇದೆ ಅಂದರೆ 24 hours ತ್ರೀ ಲ್ಯಾಕ್ ಲೀಟರ್ಸ್ ನಾವು ಟ್ರೀಟ್ ಮಾಡೋದಾದರೆ ವಾಟ್ ಈಸ್ ಫಾರ್ 4 hours? ಇಟ್ ಈಸ್ 500 ಮೀಟರ್ ಕ್ಯೂಬ್. ಕನ್ವರ್ಟ್ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀನಿ ನಾನು ಲೀಟರ್ಸಿಂದ. 3 ಇಂಟು 10 to the power 6 in divided by 10 to the power 3 gives you the meter cube, into 24 divided by 4 gives you 500 meter cube. So the capacity of the tank is 500 meter cube. Now they have given length of the tank required. What is the we have to calculate the length of the tank. Sorry, length of the tank is zero point 0.1 meter per minute. The flow velocity, because it is a rectangular tank, the flow will be horizontal direction. So it is zero point 0.1 meter per minute into 4 hours, because water which enters the tank leaves the tank after 4 hours with a velocity of 0.11 meter per minute. Means what is the length required? That's simple, zero point 0.1 into 240, which is 24 meter. Once you know the length of the tank, you can find out the cross sectional area, which is volume by length. So divide 500 by 24, you get 20.8 meter square. So you have got the length of the tank, you have got the cross sectional area. You can assume the depth. Depth is 3 meters. Note, the depth of the tank is kept between 3 to 4 meter, inclusive of allowance for storage of sludge. Therefore, width of the tank is equal to, see, length of the tank you got the cross sectional area of the tank. Okay. Now we can find out breadth. What is the breadth of the tank or the width of the tank? That is nothing but cross sectional area divided by height. And the cross sectional area is 20.8 meter square divided by 3. You get 6.9, take it as 7 meter. So length of the tank is 24 meter, width of the tank is 7 meters, and depth of the tank is 3 plus zero point 0.5. In some places 0.5 sludge is also taken. It is 4 meters. So 24 by 7 by 4 meter is to be constructed. For the same capacity, for the same amount of wastewater, if somebody asks you to design a circular tank, what do? You have to design. So volume of the let us see the circular tank design. Volume of circular sedimentation tank is generally provided with bottoms cone shaped with a slope of 1 vertical to 12 horizontal. So volume of the tank is given by a formula d square into 0.11 d plus 0.75 d, where d is the diameter, h is the depth. So what is the volume required? We know 500 meter cube. It is equal to d square into 0.011 d plus 0.785 into 3. So if you apply by trial and error, you get d is equal to 14.2 meters. So provide 14.2 meter diameter and 4 meter the depth of the tanks. So using this equation, volume of a circular tank V is equal to d square into 0.011 d plus 0.7 d 0.785 h. We can calculate the dimension of the circular tank easily. So these are the reference I have used. This is given by question. Thank you.